Yeah, very good evening to all. I'm audible. I think I'm audible. So very good evening to all. Thank you for joining. So very good evening to Bharat Raj Singh. So Mike, very good evening. So today's session we are gonna see FIFO-memory, how to write the Verilog code. So what is FIFO-memory? So what is the purpose we are using FIFO-memory? So where we are using in our IC. So we'll see in this session. Yeah, good evening to all. Thank you for joining. Kanika, good evening. So let's wait for a few minutes so remaining people have to join. So and then we will start the session. So we are gonna see FIFO-memory. So Sri Krishnan, very good evening. Venkataraman Reddy, very good evening. Good evening to all. So FIFO-memory is very important thing. So in this scenario, like if you having master and a slave, so both master and a slave works based on different clock frequency. So there is no synchronization of clock. So that's the case. We can use the FIFO memory to transmit the sequential data or serial data from high frequency master to low frequency slave. So let's see how it happens in the scenarios. So very good evening to all. Thank you for joining. Thank you for your presence in this session. So today we are going to see FIFO-memory, and tomorrow we are going to work with FEJ. So we'll start with the basic LED blinking, and then sound segment and motor control using FEJ. So and then we'll write the code on the day itself. So I think we'll start the session. So basically FIFO-memory. So FIFO stands for first in first out. So it's like a queue. So if you are in the ticket counter or any counting queue, so first person will go, he will come out by first. So there is a like a if you stand in a queue, if you are the first person, means you will come out the first person. So this is a first in first out. So if first input will come as first output. So this is a basic stands for FIFO-memory. So that we can use for memory also. So we can use this as a memory. So let's see how it is works. So this basic architecture. So and then we move to draw the FIFO-memory. So I just use my whiteboard to draw the FIFO-memory. So in the FIFO, so basically FIFO is like a queue. So it having n number of positions or blocks. We can, like, it's like memory locations. If you imagine it as a FIFO memory, it has n number of locations, memory location. If the if this is input, this is output of FIFO. Sorry. FIFO memory. So this is the input of FIFO memory. Output here, this is if the first input comes here, and then it at every passage or every net gauge of signal, it will transfer the location. So I'm continuously writing, it means writing. So we can say this is a write pointer. So and then it is a two port, so we can read, and it is like a two port memory. It has a write signal and read signal. So this means write signal is already is a read signal. So it's like a pointer. So it's like a pointer. So based on the pointer only, it will write and read in the FIFO memory. So if it is 0, it is 1, it is 2, 3, 4, 5, 6. So it has 6 memory locations, 7 memory location. So we have to point the memory locations. For that we are using pointer. So if the right pointer is 0 means I can write in the first memory location, 0th memory location. If my right pointer is 0, if it is 1 means I can write in this location. So in this location, so we can write in the every which location I want, I can write by using the right pointer signal. And also read. So if you want to read means you have to use the read signal. So read pointer signals. If the read pointer is 0, it means I can read from there. But in the at that time, if you are writing or reading in the FIFO memory, if you are read means on that time your write will be 0, so it means off. So write will be in the off condition. So then only we can read. While writing means you can so how to say in the particular location, in the particular memory location, for if you are writing means in the particular so if you example one, in the first location your read signal will be low if you are writing. So this is that. So basically FIFO memory is a circular based memory. So it means it will continuously, it's like a cyclic operation. So imagine it's like a cyclic FIFO memory. So this is the initial stage of FIFO. So it has n number of memory locations like this, up to or up to 64. It will start from 0, 1, 2, 3. So we have two pointers, like we have the read signal and write signal. So if I'm this is right, I think this is so this is a initial stage. So it having memory location, this is 0th memory location of FIFO memory, is first memory location, second memory location, third memory location, fourth memory location, fifth memory location. It will go up to whatever our memory size. I am using like a 16 byte memory location. Each and every, this is memory location, each and every memory location I can store 8 bit of data. 8 bit of data, so it means 16 byte memory location, 16 byte FIFO memory. If I want to write means I have to use write signal. So firstly we have to set condition. So what is FIFO full or FIFO full condition, empty condition. So for that I am using counter. So initially counter is equal to 0. If I am writing, so if I do writing means I will first write this memory location, and I will go first location, second location, third location. So each and every location I'm increasing my memory location. So it means I will change my count. So in the first count, after the first location writing, it will move to 1, and then it will move to second location. It will increase, my count will be increased. So in the third location my count also increase. Every time I'm writing for new location means I will increase my count. So up to if I write all 16 byte memory location, if I write all 16 memory location means my count will be 16. So if my count equal to 16, if it is count equal to 16 means I said this my FIFO memory is full. So this is a full condition, FIFO full condition. If my count equals 16, it means my all memory location in my FIFO memory are returned or occupied some data. So I can say that it is I can say my FIFO memory will in the full condition. Let's say full, it is full. So we'll move to empty condition, empty state. So if it is 16 means it is full, FIFO memory is full. If it is less than 16, so if I read means if I'm firstly I'm going to write a write operation. So now I'm going to use read. So read from the memory. So read from the FIFO memory. If I read the first memory location, 0th memory location, and then same time I will decrease my count value because of I read it from one memory location. So I have to reduce the size. So I have to reduce the count. So for that 16 minus 1 15. So if it is less than 15, so if it is less than 16, so less than 16, I can say this is my FIFO memory is in empty. So this is a thing. So the first full condition is if my when I can identify my full condition of FIFO memory is if count equal to 16, and then if it is less than 16, my count will be less than 16 means I can say my FIFO memory is in the empty. So there is empty space or empty location. So this is not in empty condition, so we can write into my FIFO memory. So based on these conditions only I can easily understand. So if full means count will be 16. So if count is 16 means I can say my FIFO memory is full, so I can't write into memory. So empty means count will be less than 16. So something else there. So it means if it is 15 or 14 means there is a remaining one space, or if it is 13 means there is a remaining 3 memory location to write. So I can write into that. So this is a simple single clock FIFO memory. So it will change the memory location by using the pointer, and then by using the write signal and the read signal I can write into the I can write into the memory. So while if you do writing means so firstly first condition is your FIFO is not full. So FIFO full, it is not in full condition. So if it is full means I can't write into FIFO, so it is not in full condition, and this is my first point. And then second point is write signal is must be high. So write signal is high, and then or else read signal must be low for write condition. So and then third condition is so empty, my FIFO must be empty. So empty equal to high. So empty equal to low. If it empty is high means it is in the empty condition. If it is low means there is a space I can write into memory. So these are conditions of writing into memory. So for reading out from memory means so for reading condition, read condition, FIFO my first condition is FIFO memory it's not in empty condition. So there is need to some values in there is there is something have to inside our FIFO memory, then only I can read from the memory. So first condition is there while reading from the memory means it is not in the empty condition, and then my read signal will be high, or a write signal will be low. So this is a condition. If it is read signal high means I can read, if it is a write low means I can also read. So this is a condition. And then uh, so and then pointer, so read pointer, write pointer, so based on the pointer only I can read the memory locations. So these are conditions we have to go, we have to write the RTL code. So these for these are FIFO memory. So and then so here why FIFO is needed. So it means you have one device, so it is device 1, it is device 2, device 2. So it will this the device 1 clock is 50 megahertz. So and then device 2 clock is device uh, 100 megahertz. So there is no same clock frequency. So if you transmit the some signal means there is a delay. It will works based on the low frequency. Low frequency. This device is works based on the high frequency. So high frequency, it's a low frequency. So this works based on low frequency. For this condition we can't transmit data directly. So if you transmit means there is a delay, it will receive fast but it will send fast. So this device 1 will send the data slowly, but for this D2 device 2 it will receive and it will receive the data very fastly. So device 1 it's not having capable to send the data fastly. So there is no chance, there is a chance to make a error or unknown state, some conflict of from the data. So there is an uncertain will happen. So for this condition we can use a FIFO memory to make proper data transferring using FIFO memory. So these are memory locations. So these are memory locations. So firstly D1 will give the output for FIFO memory. So and then it will from the FIFO memory it will read. So device 1 will give you, so it's like a connection between the D1 D2. So by using the FIFO memory in between the two different frequency devices we can make data transferring smoothly without any conflict of the data or without any error some things. So this is why we need a FIFO memory in the digital circuit to make the if you both signals for both devices they are having different frequency. It has 50 megahertz, it has 100 megahertz clock. So there is a different frequency. So if we transfer data means there is a chance to get wrong values or unknown values. So there is a mismatching of speed. So we have to maintain correct speed. For that we can make a smooth communication between D1 D2 by using FIFO memory. So why? Because of in the first if you take in D1 at every 50 megahertz clock it will store it will assign the data to memory. So it will just transferring into memory, and then at every 100 frequency seconds, like 100 frequency speed, it will receive the data. So there is no conflicts or there is no speed, so speed mismatching like that. So there is no speed mismatching, so we can use flip-flop for the smooth communication. So this is the content. So this is reason why needed flip-flop, why needed FIFO memory, FIFO. So let's see the RTL code, how to write the code. So for that So this is the architecture of the FIFO memory. So these are the signals. So write, it's one signal, and then write data, it's input data. So write data is output data. So this is output of FIFO memory, this is input of the FIFO memory. So and then write enable means we can write into memory. So read enable means we can read from the FIFO. So and then full condition, empty condition. So full condition means if the counter if the memory location are if all memory location are filled means our FIFO memory will be our FIFO in the full condition. So how we can know means by using counter we can count the writing operation, reading operation. If it is write and read and write operation is 16 or anything it is your wish. If it is size of your memory means, so we can say it is a full condition. If it is less than memory location, if the count is less than memory location means this is in the empty we can say it is in the empty condition. So based on the count value we can say full and empty. And also by using the pointer, right pointer, read pointer, we can write into memory from read out from the memory. So this is the FIFO architecture. So these are the application why we are using FIFO. So buffer management, so data streams, audio or video using FIFO or maintain the smooth flow and audio lag. So and then cache memory to handle the request efficiency while managing the FIFO, while managing the memory usage. And then task scheduling, so operation in multi-threading or process of queuing, follow the FIFO to avoid the deadlock. So these are the applications. So these are the main reason why we need the FIFO to manage the buffer management, cache memory, and then task scheduling. So these are the reason why we need the FIFO. So our main signals are FIFO. So if you are going to write means firstly we have to aware of the signals. So first signal is clock and reset. See, this is the first signal. So based on the clock edge only it can write into memory or it can read or full write, anything will happen. So based on the clock only FIFO will work. So first signal is write, so write signal is first signal. So and then read signal, so write enable, read enable. So and then input, so we can say it's a FIFO in. So this is a FIFO out, we can say also. So and then full, so full is my output, so this output signal. Full and empty are my output signals. So pointers, we can write, we can say it is a it's like a variable, so we can use for counting purpose. So counter pointers are we can use inside our code to make the logic correctly. So our main signal is clock, reset, write enable, read enable, and then full and empty. So and then FIFO out, FIFO in. So my input signals are clock, reset, FIFO in, write enable, read enable. So these are the 5 signals for my input of the FIFO memory. So my output signal is FIFO out and then empty or full. So this is my output signal. So we'll see the RTL code. So before going to that, it's time for, so if you guys are really interested, you can convert this masterclass into 1 month internship. So internship on FEGA. So you will get the benefits. You already said no, all 30 days recording session, all 30 days presentation, exclusive project codes, so and VIP community group for your doubt clearing. So and then you will get the IET internship confirmation letter. So and then you will get also 90 days LMS course access. So and then you will get the assignment and task. So we are providing also weekly live sessions, resume building, mock test. So and then you will get also internship and participation certificate from the 1 month internship. So and then these are the benefits you will get at the discounted fee of just 999. So our regular fee is 399. So in this session period we are providing at the discounted fee of just 999. You can join our internship by using this internship registration link. So this is limited time period offer. So if you guys are really interested, you can join our course using this link. So let's move to coding part. So already I written the code. So because of it will take so much time to write the design code and Testbench code. So firstly I will show my signals. So you can see here, these are my input signal: clock, reset, write enable, read enable. So this is my input signal, and then and also my FIFO in. So these imagine this is come from this device 1. FIFO in is my 8-bit input. So I can store in each memory location of 8-bit data. So 1 byte. So 1 byte of data I can store in the each memory location. So and then I will get output of FIFO is 8-bit of data from the one memory location. FIFO out, FIFO in. So these are my inputs: clock, reset, write enable, read enable, FIFO in. So and then FIFO out my output signal. So FIFO full and FIFO empty is my how to say, control signals, control signals. So and then counter, FIFO counter for the transitioning of the one memory location to another memory location, and also used for read and write. So reading and writing based on this counter only. So in my FIFO, in my current FIFO logic, I'm gonna write I'm gonna write particular location, means I have to use counter only. Based on the counter value only I can write. So it will, so I can't directly write from particular memory. So I'm gonna write only for 1 by so I'm gonna write how to say, so I'm gonna write only the each and a increasing order of memory location. It means if I having the 15 bits, like a 16 memory location, means I will go one by one only. So 0th memory location, 2, 3, 4, 5. So I will go one by one. So based on the count value, it will initially 0. So if I write enable is high, means so I can write from this memory. I will go next, I will go next, I will go next, I will go next. So by using, so I can't go from 0th to 5th location from this logic. So from today only, from today I will try only the sequential writing. So it means I will write the one by one. So first location, second location, third location. It's like a sequential location. And also I can read out from by sequential operation only. So based on the counter value, I can write into memory, and also I can read from the memory. So this is my signals. So and then I'm use 2 pointer. So I will use 5 down to 0. 5 down to 0 means 6 bit of pointers. This particular variable, it having 6 bit. It means 2 power 6 is equal to 64. So see, I can, so I'm having you can see this is my FIFO memory. So this FIFO memory, so it has 64 memory location from 0 to 63. It has 64 memory location, and then each and every memory location I can store 8 bit of data. So this is a FIFO memory. For pointing this 64 memory location, I have to use 6 bit of address. So 6 bit of pointer. So this is why we need 6 bit, means 2 power 6. So if you are using 4 bit means you can cover up to 0 to 15 only. 5 means 32, 6 means 64. So by using 2 powers 6 bit of address, I can cover from 0 to 64. So for that reason only I am using 5720 here. So and then I will move to the FIFO counter. So FIFO. So if FIFO empty means in the my FIFO counter having 0 means I can say there is no data inside my data inside memory, so we can write into memory. So it FIFO memory. So this is a empty state. If FIFO full, where when means if the FIFO counter will 64, so it means a counter 64 means I already written from 0 to 63 and also 64. So I will already return 64 memory location. So there is no memory location to write the data. So I can say this is the state in for FIFO full condition. So if counter is 0 means empty condition. If counter is 64 means it's a full condition. FIFO memory full condition. So and then this is my so this is for counter operations. Counter operation for to know the full and empty condition. So and then move to the how counter will work. So you can see here at the every passage of clock or neckage of or passage of reset. So it will, if it is triggered means if any one of signal or any one of passage is triggered means it will execute this block. So firstly I am written what is my reset condition. If my FIFO in the reset condition means my I will say my counter, if FIFO counter will 0, and then so in the reset condition. So if it is not in the reset condition, I will check this condition. So my condition is if FIFO full. If it is not full means, so you can see this is a not symbol. So a logical not. So this is a logical not. If you use this symbol like it is a bitwise not, and this is a logical not symbol. So if a FIFO full, so it is means it is not in my FIFO memory is not full. So and then write enable. So write enable, if it is write enable is high means, and this is if it is true, and then I will check another condition, FIFO empty. So if empty also low, so and then read enable is high. So it means it is not in full condition, it is not in empty condition. So both are having the read and write. So it means I'm just assigning counter equal to whatever it having counter FIFO counter value, I'm just assigning to the FIFO counter. So it means both reading and writing operation are performed in the same location. So that's why I'm assigning like this. So and then if FIFO is not in the not full condition, like FIFO is not full means, and then write enable is high. So here it means FIFO is not in full condition, and also write enable is high. So write means I can write into memory. For that certain condition I just increasing my counter. Why? Because of it means I'm writing, so I'm writing into memory. So I must have to increase my counter to change the next memory location. So this is the condition for the writing operation. If it is empty, so if it is not in empty condition, FIFO is not in empty condition, so there is a data inside my FIFO, and also write and also read enable. Read enable is high means I can read from the memory, and also you can see here I am decreasing my counter. So FIFO counter -1. So that particular value I am assigning to the FIFO counter. It means I am just reading from the memory, so I can if I am reading means, so I can reduce my memory space like in the FIFO. So if you write means it will increase the counter. If you writing in means it will increase your counter, FIFO counter. If you are reading means it will decrease your counter. So if anything happens, so if the none of the signals, if the none of the conditions will not happening means I just assuming my FIFO counter equal to FIFO counter. So and then so this is for read from the FIFO. So basically you know that the passage of clock, so always clock in the reset condition my FIFO out will 0. This may output signal it must 0 in the reset condition. So and then it will comes here if read enable is high. So high means I can read the data from memory. So and then at the same time my FIFO is empty. So my FIFO is empty. If it is not in empty, so it is not symbol. So my FIFO is it not in empty condition means, so there is a data in from the FIFO and there is a high in the read enable, so I can read from the memory. So I'm just reading from the data from the memory, FIFO memory. How means, so this is a variable FIFO underscore mem. So this is my memory. You can see this is my memory, FIFO memory. I'm just accessing that memory here and then read pointer. So it means, so based on the pointer value, if the pointer is 1 means FIFO memory of 1. So that particular memory location, whatever it having the FIFO memory, it will assign to the FIFO out. So I'm just reading from the FIFO memory using this condition. So otherwise, if it is not in reset condition, so sorry, if it is not in this condition or read condition, I'm just assuming FIFO out will be 0. So already FIFO out will be 0. So I'm just assuming that 0 will be assigned to FIFO out. So it may be stay in the 0 only. So this condition is for the write to memory. So write enable is high. It means I can write into FIFO, and then my FIFO not in the full condition. So it means my FIFO my FIFO is not in the full condition. It means, so there is a space, so there is no full condition, so there is a space in memory location which I can write. So this is a condition for that my FIFO is not in the full condition, and then my write enable is high means if both are high, so if the both condition is true means I can write into memory. So how means, by using the right pointer. So this right pointer is representing the memory location of the FIFO memory. So this is my memory FIFO memory variable name. So it is memory name. You can see here this is my FIFO memory name. So on that memory, from the memory, based on the pointer value. So if the pointer value is right pointer value is 5 means in the fifth location of FIFO memory I am writing the data. So sorry, here I am writing the FIFO in. So whatever your input is, it will assign to the fifth memory location of the your FIFO memory. So this is that. So and then if it is not in this condition, it will execute else condition. So I'm just assuming the whatever it having, so I'm just assuming to FIFO memory. So and then here this always block is for pointer condition. So right pointer and read pointer we have. At the reset condition, both pointer must have 0. You can see here I am using the flower bracket. It means concatenations. So concatenation is nothing but I am combining. So I'm just compiling, like I'm just grouping the two signals. So by using concatenation we can do that. So tool means first 6 bit for this right pointer, and then second 6 bit for this read pointer. So I'm just assigning 0 for both pointers in the reset condition. So and then if my FIFO memory is not full, and then write enable is high, if both are true means I can increase my writer pointer. So writer pointer starts from 0, and then it will write the first 0th location and then first location, so it will continuously increasing. So if it is not in if it is false means, if this condition is false means it will execute this. So and then same for read. So my FIFO is not in empty condition, so it is means there is a space I can write, so I can, so sorry, it is not in empty means we can read. If it is not in empty, it means we can read the data from FIFO memory. So if the FIFO empty, so if it is not in empty condition, and then read enable is high, so it means I can read from the memory. So I'm just reading from the read pointer, so it will start from the 0, and then it will increase up to 1 2 3 4 5. It will continuously increasing the read pointer by using this counter. So this is why counter is important in Verilog. So based on this condition I am increasing my read pointer. So based on this condition I'm just increasing my write pointer. So main signals are FIFO full, FIFO empty, and then so this is a main signal. If it is full means we can't we can't write. If it is empty means we can't read. So this is a main thing. So if it is empty means we can't read from that memory. If it is full means we can't write into memory. So this is a design code for FIFO memory. So and then let's check the Testbench. So this is my signals, already said no. So this is my instantiation clock. This clock is represents to current module clock. This clock is from the design code clock. This reset is a current module Testbench reset. This reset is a design code is this reset. So and then same like for all the signals. So I'm just creating the clock generation of 100 megahertz. So we can see in yesterday also I said here, if delay is 5 nanosecond means the frequency of clock is 50 megahertz. So here delay is delay is 10 nanosecond means the frequency of clock is 50 megahertz. If delay is 5 nanosecond, this is 5 nanosecond, so it means this clock, if I'm toggling the clock at every 5 nanosecond means it is a 100 frequency clock, 100 megahertz frequency clock. So and then I'm just initialize my signals, reset high, write enable low, and then read enable low, FIFO in also low. So this is my input. So after 20 nanosecond I just off my reset. It means on reset equal to means my FIFO, I am saying that my FIFO memory is in the reset condition. So on that time all the signals must have 0. So after 20 nanosecond I'm just off the reset condition by this reset equal to 0. And then I'm just write the first test case. So $display I'm going to write a single, I'm going to write a single write and read. So write enable is high means, so it means I can write into memory. So this is a FIFO in. So my FIFO in is in the first location. I'm storing AF5, so it is hexadecimal value, 8 bit of value. So and then write enable low, and then read enable is high. So it means I am reading from the memory. So here you can see I'm just writing some condition here. If FIFO out in this particular test case, FIFO out it is not my FIFO out is not equal to 8 bit of hexadecimal A5 means I will print this error like a data mismatch. So I'm just storing the first memory location, hexadecimal of A5. So I must read the same value. If I'm not reading the same value means I'm just printing this error message like a data mismatch happened that particular location. So this is the condition for filling the full memory location, like a filling the full memory, like a full FIFO memory. So write enable is high. So while it will do up to while it will work up to FIFO is full. So when it will full means my it will full at the counter will be 64. So in the 64th, so if the counter is a 64 means I can say it is in the full condition. So it will check up to full condition. I'm just writing the it will write up to full condition, and then in this case I'm reading from the FIFO memory from all the memory location. So empty I have to in this condition I'm just emptying my FIFO memory. I just read from 0 to 64. So and then in this case I'm just concurrently I'm just reading and writing both both by using the different scenarios. Firstly I'm reading I'm writing into memory, and then I'm reading from the memory. So and then I check the overflow. So firstly we'll see the some output here. So you can see here my write enable is high, and then read is 0. My input data is A5. So my output data is low. Why? Because of I'm still stay in the right condition. So you can see here, you can see this line. Here write equal to 0 and read equal to 1. It means I'm reading from the memory. My data is 0 A5, so it means hexadecimal A5. And then you can see here my output of at particular 35 nanosecond d out equal to A5. So whatever I am written from the first location, I'm just reading from the same location, like a first location I'm just reading A5. So that's why I didn't receive error. So I just here I'm just written some self check Testbench here. If my FIFO out not equal to A5 means it will display this error, but I can't see that message, so it will works correctly. So this is for single write and read. So this is a FIFO full read and write. So you can see here write is high, so it will start from 0th location. It will store some default random values like A5 like that. So I'm storing that up to 64 memory location. So I'm just writing here. So I'm just writing, you can see all the values are having the write equal to 1 1 1. So I'm just storing the I'm just writing into FIFO, and then FIFO empty. So here you can see write equal to 0, read equal to 1. So here I'm just reading out from the memory. So read is 1 means I'm just reading out from memory. So data in is 71. So my values are the output values are A5, A24, 12, 11, 0D. These are random values. Why? Because of here I'm using the $random here. So FIFO in is $random. So this is one keyword. If you using means it will give random values for input. So you don't want to write all the inputs for signals. You can also use random. So and then So I'm just reading out from memory. So you can see I'm just reading from memory. So d out equal to f5 24. You can see also count also will decrease. So I already said no. I will write the I will write the FIFO memory in like a sequential order from 0 to 24, and then I'm reading from memory from 64 to 0. So it will, you can see my count also decreasing, 64, 63, 62, 61. And also you can see my while writing the count will be increasing from 0 to 64. So this is the writing and reading of FIFO memory. So it's a overflow and underflow methods. So these are the techniques. So these are the test cases I'm written in the test bench. So this is easy only. So I'm just using simple signals. So I'm just writing the linear writing and the linear reading. So it's based on the counter only. So if you use the double board means, so if you write any part of, if you write any memory location, you can, if you can read from any memory location. So this is a complex logic. So this is very simple logic only. If I write the any location, if I read from the any location, so this is a complex logic. If I try to write means it will take 2 hours to complete to write the complete FIFO memory locations. So FIFO memory logic from random read and random write, or random write and overflow underflow conditions. So it will take time. So this is a basic understandings of FIFO memory. So how it will be full, so what is the full condition, what is the empty condition, and then how to increase the pointer, how to read the data from memory by using the pointer. So these are the basic things of FIFO memory. So I just said that only. So this is for today. So this is for today. So I will correct my voice in upcoming class. So this for today for FIFO memory writing. So I'm just writing for simple memory, simple FIFO memory. So main thing is FIFO is useful for frequency kind of things like I already said no. If you having two devices, like one is works based on high frequency, one is low frequency. If you want to make communication between them, you can use FIFO memory to send and receive the data. And also, if you do the live streaming or any high speed communication, you can also use FIFO memory. We can use for different frequencies. So these are the advantage of the FIFO memory. So that's all for today. Thank you for listening. So thank you. We'll see you tomorrow.